Okay, students, in this video we're going to be looking at graphing linear inequalities. In order to graph a linear inequality, you're going to graph the line and then you're going to do some shading, because with inequalities you have more than just one answer. A lot of things will make an inequality true. So first off, we're going to say that the slope is 2 and the y-intercept here is -3. So first we graph the -3 because that's our y-intercept, that's where we begin, and then we're going to have a slope of +2. So we're going to go up 2 and over 1, and then down 2 and back 1. Because this is equal to, we're going to have a solid line. So we'll go ahead and graph that solid line. Then I have to decide how to shade, and basically what I want to know is where is y less than or equal to the intercept. So where is y less than or equal to -3? That is things like -4, -5, and so on. So what we would graph then, or what we would shade, is all this area below that line. So for less than or equal to, you're going to have a solid line, and you're going to shade below. For greater than or equal to, because of the equals, you will again have a solid line, and you will shade above. For less than, this is like an open circle, so we kind of want an open line, so we call that a dashed line. And this one again, because it's less than, we shade below, always looking at the y-intercept to decide whether which direction that is, where below really is. For greater than, we have a dashed line, and this one will be shaded above. Okay, so it says, which of the following would be a solution to y is less than or equal to 2x minus 3? So we're going to use this point as one example. What we would do is take x and y and substitute those into the inequality. So we would have 0 is less than or equal to 2 times 1 minus 3. So this would say 0 is less than or equal to 2 minus 3, which is -1. This is a false statement. Because it is false, it is not a solution. Another way we can see that is if we just graphed the point 1, 0. We go over 1 and up 0. That point is not in the shaded area, so this is not a solution. Over here, the point 4, 5. Over 4, up 5. Use a different color. I don't like that one. Let's use this one. Over 4, up 5, right here. This is on the line, and the line is included in the inequality, so this one is a solution. So we would say 5 is less than or equal to 2 times 4 minus 3. 5 is less than or equal to 5, which is true. For -6, -2, well, that's going to go off the graph somewhere down here. Definitely not a solution. For -5, 0, we would go -5, 0. Again, not a solution. It is not inside the solution set. -5, -4, and what I'm going to do here is change this one, change this example. Let's make this a +5, -4. So if I'm going to graph +5, -4, I'll go over here to +5 and go down -4. And here we have a solution. So if I said -4 is less than or equal to 2 times 5 minus 3. So I'm going to say -4 is less than or equal to 10 minus 3, which is 7. And this statement is true. That is why we know it is a solution. Not only does it graph into the solution set, but we can tell algebraically that it is true. Solve each inequality by graphing. So what that means is you have to solve for y for both of these so that we can have this inequality in slope-intercept form, and then we'll test out each of these points on this one here. So to solve for y, we're going to get rid of the x term first, because remember it's move the x, change the sign, divide by what's in front of the y. Don't forget to simplify. So here we've gotten rid of the x value on the x term on the left-hand side. Now we can divide everything by the coefficient of y, which is 3. So we have y is greater than 2/3 x plus 2. To graph that, we will start at our y-intercept of 2, then go up 2 over 3, or down 2 and back 3. Like that's going to come out there. This is greater than. Because it is greater than, found out back here, we're going to want a dashed line like you would want an open circle. So we're just going to dash this line. And then we need to shade. Because it's greater than, we want things that are bigger than the y-intercept, so we want things that are above the line. So that's this area right up here. If you were, one of these points were on this line, it would not be a solution because this line is not included because it's dashed, because we have a strictly greater than symbol. So -1, 0 is right here, so not. 0, 0 is right here, not. I guess I should say not a solution. Not a solution. 6, -2, so that's out here somewhere. Again, not a solution. These would all give you false statements with the inequality. Over 3 and up 1, not a solution. And finally 2, 5. Over 2, up 5. And finally we get a solution. So again, this is a solution because it is inside the solution set area. But we could also say that 5 is greater than 2/3 times 2 plus 2. So 4/3, that's 4/3 plus 6/3, so that would be 10/3. And 5 is definitely greater than 3 point, see, 3, so 3 times with 1 left over, so this is going to be 3 repeating. Or 10 divided by 3 is 3.3 repeating. So 5 is definitely better than 3 and a little bit more. So here we have this number 1 and these solutions there. So we still need to graph the last one. Again, get rid of the x. So I have -3y is greater than or equal to -x minus 6. Divide by -3. Remember the golden rule, whenever you multiply or divide by a negative number, you're going to flip the inequality symbol. So you're going to get y is less than or equal to 1/3 x plus 2. We go to the y-intercept, then we use the slope 1 over 3 to get some more points. And this one, because of the equals part, is going to be a solid line. Because of the less than part, we want things that are smaller than 2 on the y-axis, so that's going to be below the line. So here we have graphing linear inequalities. First thing, you have to solve for y, paying special note to the golden rule that if you had to multiply or divide by a negative number, that you will then flip the inequality sign. Then you make sure that you have a solid or a dashed line, shading above or below based on the location of the y-intercept, and those things that are either smaller or bigger than that, depending upon where the inequality sign will take you. This one being greater than, we wanted values of y that were bigger than 2, and on this one we wanted values that were smaller than 2. So this is graphing linear inequalities. And if you have any questions, please come to tutorials.